Hello friends, welcome to video lecture on kinematics of machinery. In today's session, we'll learn about the belts topic. Under this, we'll study introduction and types and other fundamentals of belting. So let us continue with the belt. The belts or rope are used to transmit power from one shaft to another by means of pulleys which rotate at the same speed or at different speeds. The amount of power transmitted depends upon the following factors. First one, the velocity of the belt. The next one, the tension under which the belt is placed on the pulleys. Third point, the arc of contact between the belt and the smaller pulley. The condition under which the belt is used. So these points should be noted about the belts. The shaft should be properly in line to ensure uniform tension across the belt section. Second point, the pulleys should not be too close together in order that the arc of contact on the smaller pulley may be as large as possible. The pulleys should not be so far apart as to cause the belt to weigh heavily on the shafts, thus increasing the friction load on the bearing. The next point, a long belt tends to swing from side to side, causing the belt to run out of the pulleys, which in turn develops crop spots in the belt. The tight side of the belt should be at the bottom so that whatever sag is present on the loose side will increase the arc of contact at the pulleys. In order to obtain good results, which with flat belts, the maximum distance between the shafts should not be exceeds than 4 meter and the minimum should not be less than 3.5 times the diameter of the larger pulley. Then selection of the belt drive. Following are the various important factors which on which the selection of the belt drive depends. First one, speed of the driving and driven shaft. Second one, speed reduction ratio. Third one, power to be transmitted. Then power to be transmitted, centered distance between the shafts, positive drive requirement, shaft layout, space available, and last one is nothing but the service conditions. Okay, on these points, the selection of the belt drive is done. Okay, so types of the belt drives. First one is nothing but the light drives, then next one medium drives, and next one heavy drives. So light drives, these are used to transmit small powers at belt speeds up to about 10 meter per second, as in agriculture machines and small machine tools. Next one, medium drives. These are used to transmit medium power at belt speeds over 10 meter per second but up to 22 meter per second, as in machine tools. Heavy drives, these are used to transmit large power at belt speeds above 22 meter per second, as in case of the compressor and generators. Now see the types of belts. So first one is the flat belt, next one V belt, next one circular belt. Depends upon the cross section, we can decide the various actually types of the belts. Okay, and depends upon the distance and other things. Now just see here the flat belt. The belt as shown in figure is mostly used in the factories and the workshop, where the moderate amount of the power is to be transmitted from one pulley to another when the two pulleys are not more than 8 meter apart. Now here second case, that is V belt. The V belt is mostly used in factories and workshop where a moderate amount of the power is to be transmitted from one pulley to another when the two pulleys are very near to each other. Next one, circular belt or rope. The circular belt or rope is mostly used in factories and workshop where the great amount of the power is to be transmitted from one pulley to another when the two pulleys are more than 8 meter apart. If the huge amount of the power is to be transmitted, then the single belt may not be sufficient. In such case, wide pulleys with a number of grooves are used. Then a belt in each groove is provided to transmit the required amount of power from one pulley to another. Now see the types of flat belt drives. The power from one pulley to another may be transmitted by any of the following types of the belt drives. First one, open belt drive. Now just see here the arrangement for the open belt drive. The open belt drive is used with the shafts arranged parallel and rotating in the same direction. So in this case, the driver A pulls the belt from one side and delivers to the other side. Thus, the tension in the lower side belt will be more than the upper side of the belt. Okay, so the lower side belt is known as tight side, whereas the upper side belt is known as slack side. Okay, so as shown in the figure, if you just see here, both the pulleys are rotating in the same direction. So here this R to Q, the pulling action will take place, and from L to M points the pushing action will take place. So this becomes the tight side and this becomes the slack side. Okay, now next take is a cross or twist belt. Okay, now when both the pulleys are moving in opposite direction, then this is the case of cross or the twist belt. Okay, the cross or twist belt is used when the shafts are arranged parallel and rotating in the opposite direction. In this case, the driver pulley. So we just see here is the driver pulley and here is the driven pulley. Okay, case of the driver pulls the belt from one side and delivers to the other side. Thus the tension in the, here if you just see here, RQ be more than that of the LM. Okay, so the RQ is known as tight side, whereas this LM is known as a slack side with respect to this cross or twist belt drive. Now just see the next one, quarter turn belt drive. The quarter turn belt drive is also known as a right angle belt drive, as shown in this figure. Okay, is used with the shaft arranged at the right angles and rotating in one definite direction. In order to prevent the belt from leaving the pulley, the width of the face of the pulley should be greater or equal to 1.4 B, where B is nothing but the width of the belt. In case of the pulleys cannot be arranged, or when the reversible motion is desired, then the quarter turn belt drive with the guide pulley may be used in this way. Okay, so as per here discussion given, whenever we want to transmit the power at a right angle, then such arrangement can be required. Okay, or this is known as quarter turn belt drive. Okay, so here you can use the guide pulley for the same actually thing, quarter turn belt drive with the guide pulley. Now just see the next one, belt drive with the idler pulleys. A belt drive with the idler pulley. So this is actually shown with respect to these diagrams, is used with the shafts arranged parallel, and when an open belt drive cannot be used due to small angle of contact on the smaller pulley. This type of the drive is provided to obtain high velocity ratio, and when the required belt tension cannot be obtained by other means. When it is desired to transmit the motion from one shaft to several shafts, all arranged in parallel, a belt drive with us many idler pulleys. Now if you just see here, here is the driver pulley with us, here is the driven pulley with us, here is the driver pulley, and here is the driven pulley with us. So whenever the driving shaft start rotate, so here in this case this will start also moves in the same direction. Okay, see the arrangement is here parallel. What is the function of this one idler pulley? That will extend the tension in that pulley arrangement, and the amount of the power transmitted is also increased. Now if you just see here, here is the driving driven pulley with us, here is the driver pulley with us, from which the belt is wrapped on its external surface. What's about this one? These are indicate the idler pulleys. So with the help of this one, we can increase the tension in that belt drive. So amount of the power is also is increased because of that increase in the tension. Okay. So when it is desired to transmit the motion from one shaft to several shaft, all the arranging in the parallel and the belt drive with the mini idler pulley, this arrangement is here. Now if you just see the next one, compound belt drive, a compound belt drive arrangement, okay, is shown in this figure, is used when the power is transmitted from one shaft to another through a number of pulleys. Now just see here, one pulley, another pulley is arranged here, and next pulley is here. So here is the driver pulley, here is the driven pulley. Now when the two pulleys are mounted on the same shaft, okay, this is known as compound belt drive arrangement. So next one, step or cone pulley. A step or cone pulley drive in this way, that step or cone pulley drive with us used for, and this is used for the changing the speed of the driven shaft while the main or driving shaft runs at constant speed. This is accomplished by shifting the belt from one part of the step to the other. If you just shift the belt from one actually a pulley to the another one, automatically the velocity ratio will be changes, and we can just get the speed increase in the speed. Okay, what's about the next one? This is the case related to the fast and loose pulley drive. A fast and loose pulley drive is used when the driven or machine shaft is to be started or stopped whenever the desired without interfering with the driving shaft. A pulley which is keyed to the machine shaft, as here the pulley which is keyed with the machine shaft is known as fast pulley and runs at the same speed at that of the machine shaft. Okay, and if you see here is the fast pulley and here is the loose pulley. A loose pulley runs freely over the machine shaft and is capable of transmitting any power. When the driven shaft is required to be stopped, the belt is pushed on the loose pulley by means of sliding bar having the belt force. Now in this way, without actually disturbing to a main system, we can use this fast and loose pulley drive. Now we'll just see the velocity ratio of the belt drive. So it is the ratio between the velocities of the driver and the follower or driven. It may be expressed mathematically as discussed below. So here let us consider d1 is the diameter of the driver pulley, then d2 is the diameter of follower. N1 indicate the speed of the driven in rpm, N2 indicate the speed of the follower in rpm. So length of the belt that passes over the driver in 1 minute is the pi d1 n1. Similarly, the length of the belt passes over the follower in 1 minute is the pi d2 n2. So as the length from both the sides is same, means this term and this term must be same. Okay, so pi d1 n1 must be equals to pi d2 n2. So velocity ratio is nothing but here, so pi get cancelled, so n2 by n1 equals to d1 by d2. If I consider the thickness, then n2 by n1 equals to d1 plus t divided by d2 plus t. Now we will discuss about the slip of belt. What's about the slip of belt? So already I have discussed the motion of the belts and the shafts, assuming a firm frictional grip between the belt and the shafts. But sometimes the frictional grip becomes insufficient. This may cause some forward motion of the driver without carrying the belt with it. This may also cause some forward motion of the belt without carrying the driven pulley with it. So this is known as slip of the belt and generally expressed as percentage. The result of the belt slipping is to reduce the velocity ratio of the system, as the slipping of the belt is common phenomenon. Thus the belt should never be used where the definite velocity ratio is of importance. So let us consider S1 percentage is the slip between the driver and belt. S2 S2 percentage indicate the slip between the belt and follower. The velocity of the belt passing over the driver per second is nothing but here v equals to pi d1 n1 divided by 60 minus pi d1 n1 by 60 multiplied by s1 divided by 100. Okay, so this s1 percentage means here s1 divided by 100. So in this way you can get the relation for the v pi d1 n1 divided by 60 into bracket 1 minus s1 divided by 100. So equation number 1 for this. Similarly, and the velocity of the belt passing over the follower per second, so we can get that relation in this way: pi d2 n2 divided by 60 equals to v minus v into s2 by 100. So we can get this relation in this way: v into 1 minus s2 by 100. So substituting the value of this one v from relation number 1, here is the relation number 1. To substitute the value for the v, so we can get this n2 by n1 equals to, so here 60 get cancelled, pi also get cancelled. So n2 by n1 equals to pi d1 by d2 into 1 minus s1 divided by 100 minus s2 divided by 100. Okay, this we can get the term. Relating the higher terms here, s2 multiplied by s1 divided by 100 multiplied by 100, just negate this term. Okay, so after this simplify this one, d1 by d2. So what's about this one? Minus minus, the base is common here, so minus s1 plus s2 divided by 100. So what's about this? S is nothing but the total percentage of the slip, that is s1 plus s2. If you consider the thickness of the belt, then we can get that relation in this way: n2 by n1 equals to d1 plus t. From here only d1, the d1 plus t will comes into picture. Similarly here d2 plus t into bracket 1 minus s divided by 100. Now see the creep of the belt. When the belt passes from slack side to tight side, a certain portion of the belt extends and it contracts again when the belt passes from tight side to slack side. Due to these changes of the length, there is a relative motion between the belt and the pulley surfaces. This relative motion is termed as creep. The total effect of the creep is to reduce slightly the speed of the driven pulley or follower. Considering the creep, the velocity ratio is given by n2 by n1 equals to d1 by d2 multiplied by e plus square root of sigma 2 divided by e plus square root of sigma 1, where the sigma 1 and sigma 2 indicate the stress in the belt on the tight and slack side respectively. So E indicate here Young's modulus for the material of the belt. Thank you. I hope that whatever the discussion related with the belt, the today's lecture clear to you.